Um, Nice to meet you. I'm Ellie. I'm a nutritionist and the founder of Vojo. So at Vojo, we help people um, be their healthiest version of themselves by personalizing their diet to their DNA. And that's why I was so interested in your research on the ApoE4 allele. So we'll get right into that. But first, tell me a bit about yourself.
Thank you, Ellie, for hosting me. My name is Hussein Yassine. I'm from University of Southern California, and my lab is interested in how ApoE4 affects the risk of Alzheimer's disease using many tools, including nutrition, brain imaging, basic science, and clinical trials.
Your papers that I've read are extremely interesting, and you really go into ApoE4 and the risks associated and everything like that. So, what does ApoE4 actually do?
ApoE4 is a gene variant of ApoE and encodes a protein that works in transporting lipids in the brain.
And why is that important?
Because the brain is mostly consistent of lipids, and humans have evolved to incorporate or retain a large amount of cholesterol, omega-3 fatty acids, and many other important lipids to be able to sustain neuronal firing, make synapses, and form memory. So it's part of our brain development to have a very efficient mechanism to transport and package lipids.
So, transporting lipids around the brain is extremely important. How does ApoE4 interrupt that process?
It doesn't necessarily interrupt the process, it alters its speed. So ApoE4 can carry lipids at a faster rate than non-E4 carriers, meaning that it recycles in and out of the cell quickly and changes how fast. If you take the analogy of an orchestra, ApoE4 is playing at a greater speed. The music is the same, but it's running faster, although the outcome could be the same. And that lasts decades until the system starts to fail.
So, the song is over faster as well, I guess, if the music is playing faster. So, what does it mean for human health?
What it means is that the ApoE4 brain might be a little bit more high maintenance, requiring more support to slow down or prevent the onset of dementia. And that's, by the way, is not across the board. This affects mostly white people. There is evidence that there is an ancestral variation supporting that blacks with ApoE4 may have a different response than whites with ApoE4. This homeostasis or mismatch is mostly seen in white people.
Why is there a population difference there? Do we know why there's a difference?
We have some clues. For example, 50% of the population in Nigeria carry the ApoE4 allele. They don't seem to have cognitive problems. They don't seem to get more dementia. However, we're talking about a population exposed to a lot of infections where ApoE4 is busy in the process of regulating the immune system through lipids. And that way, ApoE4 builds an efficient system to fight infections. When this gene has been transmitted into the white population, and we're talking hundreds of thousands of years ago, and when they moved into an aseptic northern climate that has, the mismatch starts to become evident on many fronts. The first front is they used to be foragers. They used to work a lot, live by the oceans, consume more seafood. And as they moved north and into the swath of land where there's less access to seafood, as the agriculture revolution changed how we live, where we can afford to be less active and live in our houses and so forth. There has been a mismatch where insulin resistance, obesity, diabetes in white people interacted with ApoE4 to affect brain aging and enhance the risk of developing Alzheimer's.
So, actually, when the gene came about, it was rather protective at the time. So, it saved us from various infections, from getting ill, and actually probably prolonged our lifespan at the time that the genetic mutation came about. Is that right?
That's correct. And it still is the case in some populations around, like, as I mentioned to you, 50% of the populations, up to 50% of the populations in Nigeria still carry the E4 allele. Around 20% of the white population carries the E4 allele. So you could see clearly that certain populations still living in our day and age have survived ApoE4 and continues to thrive with it because it's not maladaptive.
That's so interesting. So we usually see these genetic mutations as a bad thing. You know, I have the ApoE4 allele, and when I found out, I was like, "Oh my god, I'm gonna die of dementia." My dad died of dementia, which is why I found out in the first place. But actually, if you give yourself the right lifestyle and the right environment and the right diet, could someone with the ApoE4 allele live as healthy a life as someone without the ApoE4 allele?
We like to think so, although a lot more research still has to happen on what the right lifestyle would mean. We have some clues from epidemiology studies that controlling blood pressure, greater education, especially high school education and college education, certain lifestyles, including a diet rich in fatty foods such as fish and omega-3s, and behaviors including listening to music, meditation, or praying can possibly protect the ApoE4 brain. But as we speak, we still don't have strong evidence-based recommendations based on careful studies that looked at ApoE4 carriers. We're making assumptions, but we've got enough clues to make those assumptions.
What sort of studies do we need to be able to make those really strong evidence-based recommendations? Because I guess it's quite hard to, look into someone's brain and see what's going on all the time if you're making a nutritional intervention, for example.
Correct. So the studies that we do in my lab include a lot of brain imaging, where we could look at the size of certain areas in the brain, and we know there's a correlation between size and function, not a very strong correlation. For example, hippocampal atrophy often predicts cognitive decline. We've also developed tools where we label omega-3 fatty acids, inject them into mice, and then use a PET scan to see how much of the omega-3s are getting into the brain. And we've been interested in how ApoE4 affects the delivery of these omega-3s into the brain and factors that regulate their transport. There's many other tools, whether it's fancy connectivity studies where you can look at the synaptic biology and the connections between neurons using functional MRIs. These tools can allow us to assess the function of the human brain decades before somebody could get dementia.
Wow, that's pretty amazing. So how far do you think we are of making these kind of solid recommendations to people based on their ApoE allele status?
I would say a decade. Countries in Europe might have a competitive edge because of their healthcare system. In the US, we have a fragmented healthcare system where genetic counseling is not freely available, genotyping is not available. And while we do cutting edge research, translating that into a clinical recommendation might take a little bit more time. In countries in Northern Europe, especially like Denmark, Sweden, where electronic medical records are streamlined in the population, Finland is another one. The ability to identify the ApoE4 carriers and provide sound-based recommendations is easier because you've got this massive database and you've got a controlled healthcare system as opposed to a fragmented healthcare system.
Yeah, in the UK, the NHS have put a lot of money, well, the government's put a lot of money into research into genomics and this personalised medicine kind of branch of the NHS, which hasn't been launched yet and it is nowhere near being launched yet. But, we're putting the energy in now and we have been for a number of years. So that's pretty exciting. And I imagine something like ApoE4 would be one of the main areas that would be focused on, because dementia is such a huge killer in our society nowadays.
Yes, and I happen to be at the moment reviewing a paper from a group looking at the UK Biobank, and they were looking at several aspects of fish oil supplementation, fish consumption, and dementia incidence in the UK Biobank. And I would say I'm at all the database that they're reporting is 500,000 individuals followed over a period of 7 years, looking at who developed dementia and what not, and how ApoE4 is affecting that. So the UK Biobank is a very helpful resource that has been established in the United Kingdom. And one state of affair events that's relevant is we know that ApoE4 carriers, when they develop COVID, their risk of death is much higher than non-carriers. And this is finding that's driven by information of studying the UK Biobank. So this is an example of why having a strong healthcare system that's connected and run by a central organization is more efficient as opposed to a fragmented healthcare system.
Yeah, I completely agree. That's a very interesting point you just brought up, by the way. Do we know why ApoE4 carriers are more susceptible to dying from COVID-19? Or do we
Yes,
have a theory?
I don't think we know, but we think we can make a hypothesis. We know that ApoE4 carriers can have a strong immune response to infections, to clear the infections. One of the nasty aspects of COVID is that it eludes the immune system. In fact, COVID could disappear from your body, but you still develop what's known as the cytokine storm, where the immune system will be hitting itself and turning into an autoimmune disease almost. And the ApoE4 possibly aggravates or enhances the immune system response to COVID-19, where the massive cytokine storm could possibly lead to lung injury and fibrotic diseases and others.
Okay, so while it may be protective for a lot of infections, in fact, in this case, it does the opposite. Well, it's protective against the infection, but not long COVID or the cytokine storm.
Yeah, the autoimmune component of COVID.
What would you say to people? So, I have a lot of customers who do want to find out their ApoE4 status. They want to know their risk, but I also have some people who don't want to know. They're like, I don't want to know if I have an increased risk of Alzheimer's disease. I don't know. I don't want to know if I have this gene, even if there are things I can change in my diet and lifestyle to reduce my risk. Would you recommend, knowing everything, being the expert in ApoE, would you recommend that people find out their status?
It depends on where you are coming from. If you are in a place where availability to a genetic counselor or access to care is available, then maybe knowing ApoE4 and having a plan to do something about it is useful. But if you are in a place where access to care is limited, knowledge of ApoE4 may not make a difference, if possibly create anxiety.
Yeah. Okay. That's a very good answer. So with someone with the ApoE4 allele, what are the, I don't know, your top 5 recommendations to reduce your risk of Alzheimer's or dementia?
Right. And please bear in mind that these recommendations are not evidence-based, and a lot of work needs to happen before we can be strong or make strong recommendations. And however, I would urge to use common sense, and the recommendations for ApoE4 carriers hold true for non-carriers and not controversial. One is if somebody in middle age has high blood pressure, that needs to be controlled. 2, if somebody has cardiovascular risk or vascular risk factors, which include high cholesterol, they include diabetes, that has to be controlled. And it's very important to understand that ApoE4 is something we are born with. And by the time the system fails, you could argue that the horse is out of the barn. And it's important to recognize that the timing of intervention with ApoE4 is very critical. And there could be a gene dosage effect. meaning if you carry 2 copies of E4, one from mom, one from dad, you should start as early as 20. If you have 1 copy, you should be starting between 40 and 60. And when it's 65 and above, you could have irreversible neurodegenerative changes to the brain where lifestyle may not actually make a big impact. Having said that, additional lifestyle factors can include consuming, I recommend to my patients to consume 1 serving of fatty fish per week. Fatty fish include salmon, herring, tuna, sardines. These are omega-3 rich food. And the reason why we recommend that is because, as I mentioned in the beginning, the ApoE4 brain's music is faster, which means that the conductor and the musicians have to have more energy to be able to run it at this pace. And the energy to make music in the brain, to a large extent, are omega-3s. Omega-3s are needed to create synaptic connections between different neurons, and the ApoE4 brain likes to use that quite a bit. And it's possible that the ApoE4 happened or developed in a region in the world around the Rift Valleys next to Ethiopia, where access to seafood was common. And this is why the E4 carrier moving into the savannas or areas where there is limited seafood puts the ApoE4 brain at increased risk of aging diseases. Other aspects of protecting your brain include meditation, music, and praying, and being in a social protective environment, because we know depression and isolation and hearing loss increase the risk of dementia. So being in a community that supports you, and you could read about the blue zones, because I think the National Geographic has made an outstanding session on the blue zones and what makes people live longer and what protects their brains. And being in a socially connected environment with family and friends where you can talk to, play games, interact, and express yourself can protect your brain. And obviously, if you knew that you are an E4 family and you're having children, making sure that they get good education, because with higher education, you build more synaptic connections, especially between the ages of 6 and 18. So all of these components together can actually protect the ApoE4 brain.
You mentioned all of those are incredibly interesting. I want to go through them all, but perhaps we don't have time. And you mentioned omega-3. That's quite a big topic in the plant-based community because obviously, if you're plant-based, you don't eat fish. So a lot of people either eat chia seeds, which contain the ALA form of omega-3, or they supplement something like algal oil, which contains, as you know, EPA and DHA, which are kind of preformed omega-3s, which you would usually find in fish. Is this something you would recommend instead of fish?
I would rephrase the question. I would not recommend those instead of fish. I would recommend them only if somebody does not want to consume fish. Because if you have the option, I would definitely go to fish. And just to give you a simple example, if you take a piece of salmon and analyze its content, you'll realize that not only does it contain omega-3s, it contains choline, it contains lutein, it contains vitamin D, it contains vitamin E, and the complexity of the whole diet makes the transport and delivery of these omega-3s into the brain more efficient. So isolating one single ingredient, and we can argue that the single active ingredient in fish is DHA and EPA, but by themselves, they're not sufficient in producing the maximal effects. So yes, if you have no choice, of course, having the supplement might be protective, and it would take a long time and may possibly higher doses of the supplement to work because they are taken in isolation from other ingredients that are critical to package and transport these supplements into the brain.
So the DHA from a DHA supplement is actually less efficient at getting into your brain than the DHA from fish.
Correct.
Okay. Do we have studies that compare these?
Epidemiology studies have clearly shown that fatty fish consumption is associated with lower risk of dementia The literature on fish oil supplementation and risk of dementia is mixed. Some studies suggest that it has absolutely no effect, and other studies which have looked at longer duration consumption suggest a small effect.
Yeah, I guess with a lot of the studies that there are a lot of issues with studying this, aren't there? Because you have to have a very long-term study to see if there's any difference. And also, many of the studies I've looked at that have a supplement intervention or a food intervention, they're actually, or especially supplement interventions, they're already in people who are older. So these people are already in their 60s, and they're being supplemented DHA to see if it makes a difference to their dementia or Alzheimer's. And as you stated previously, just earlier, actually, you need to start if you have two alleles, both the alleles, you need to start when you're in your 20s. And if you have one of the alleles, you really need to start around your 40s. So when by the time you reach your 60s already, it's probably too late to be making those changes.
Yeah, that's correct. But I would say if you are in your 60s and you don't have dementia, there might be still a window of opportunity. It would be too late after somebody develops dementia. And then we know that dementia is associated with neurodegeneration, meaning when you scan the brain, you could see massive atrophy. In that case, it's the supplement is not going to create new neurons. It's probably not going to be effective. And that has been tested in clinical trials and found no effect. But yes,
Okay.
you're right. The actual benefit from taking the supplement is greater when you do it way before the disease starts, or at least when you can detect the disease, as opposed to waiting until the disease hits.
You bring up a very good point with fish containing a lot of the different nutrients we need, though, and many of the nutrients you mentioned are low on a plant-based diet. So actually, I do recommend that people supplement choline and many other nutrients as well, because it's simply too difficult to get them on a fully plant-based diet, especially if you need that extra support in your brain too. What if you supplemented them all together like you were eating fish, but it's just a supplement? I guess we don't have any studies for that.
Yeah, it's a theoretical argument, and unfortunately, I really can't tell how much you should take, and we have to be careful because I have seen patients who overdo it, and they have toxicities from overdoing vitamin Bs or taking too much fish oil or so forth. I certainly believe in the Goldilocks phenomena. I don't know if in the US we use this Goldilocks phenomena that it can't be too high, it can't be too little, it has to be just right.
Yeah, no, that's definitely true for everything. But yeah, again, as with food, it's actually quite difficult to overdo it, whereas it's much easier to overdo it with supplements. So you talked about yeah, no, it's not possible. So you talked about the music being faster in your brain and DHA being the one of the main components, the kind of conductor of the orchestra. You need more DHA because the music is moving faster. Uh, Basically, our brain is getting through more DHA than a non-ApoE4 carrier. What is happening to all that omega-3? Where is it going?
It's being used. So what happens is the DHA will recycle out of the membrane. The membranes are formed, they are fluid membranes, meaning that they change. And those membranes are usually allowing the conduction of electric potentials or impulses. And that's our memory is just a form of electricity. And then when DHA recycles, it ends up being broken down into small pieces and is lost. So this is like your engine oil. What happens?
Okay, so we can't reuse it basically. It's lost and we just have to replace it.
Yes, just like your car, you have to replace your oil every 3 to 6 months.
Is there anything we haven't talked about which you think is very important to mention?
I just would emphasize the most important points in this talk, which is understanding that ApoE4's risk can be changed, starting early, especially if you're a homozygote, having a varied, diverse diet that is not solely fixated on one item. So one thing, whether it's just DHA or just EPA or just ALA, may not really cut you through. You have to have a varied diet that provides different ingredients because we tend to be simplistic and reductionists in our thinking, but there's a lot of complexities that makes the human body, and cofactors and enzymes and so forth, and one size does not fit all. For those who are vegans and consume limited choices, my best advice is try to increase the consumption of fat in your diet as opposed to simple sugars or carbs. Consumption of carbs and simple sugars is associated with diabetes and insulin resistance, and that could actually worsen the risk in ApoE4 carriers. So if you are a vegan and you have limited choices, you do have to look deep and try to avoid increasing your carbohydrate consumption, because now you're not consuming fat from meat. You have to look for other sources of fat, and you cannot fixate on one source of fat. You have to have a varied kinds of fat to be able to compensate or accommodate the demands or the energy demands of the brain.
This is such a good point, because you're right. We are very reductionist. So we do tend to be very reductionist with our diet. We fixate on one thing. If you have the ApoE4 allele, you could fixate on just getting omega-3s. But yes, you're right. A varied diet and all the other components are so important, because the human biochemistry is just so complex, and you need to cover all of it. And fat is also a good point. There are studies that show that actually a very, very low carbohydrate or even a ketogenic diet can be beneficial for people with ApoE4 at risk of Alzheimer's disease. What do you think of a ketogenic diet?
I don't think the evidence is yet out there, and I think the ketogenic diet might be too extreme and not sustainable. But certainly, I think reducing the amount of carbohydrates and increasing the amount of fat could be a healthy approach. A ketogenic diet reduces that substantially to the extent that you're starting producing ketone bodies. The argument that the brain uses ketone bodies more efficiently than glucose. We still don't know if that could be used as a modality to treat the diseased brain that's not able to use glucose above the age of 65. Ongoing studies are trying to answer that. But in general, being in a ketosis style for a sustained amount of time is not tenable. Can't do that. It's too hard to do. You can do it for 3 months, 6 months, but then people revert to their own lifestyles. And I think if you want to restructure your lifestyle long term, we may have to be practical and make choices that we can sustain. And on the right direction would be decreasing our consumption of carbohydrates and increasing our consumption of fat, particularly polyunsaturated fats.
What about the level of omega-3? So there is a kind of a balancing act between omega-3 and omega-6. And if you have more omega-6, this can cause a more inflammatory effect. If you don't have enough omega-3, your brain membranes can replace the omega-3 it needs with omega-6. So as well as thinking about omega-3, do we also have to worry about omega-6?
There hasn't been clean randomized clinical trials comparing omega-3s to omega-6, but theoretically, omega-6 can be pro-inflammatory. And there has been epidemiology studies suggesting that higher levels of omega-6s is associated with forms of inflammation. We still don't know exactly how much to balance this out, but I do agree with the recommendation that tilting the balance toward more omega-3s and less omega-6 makes sense, simply because in the last 3 or 4 decades, we made it very easy to consume massive amounts of omega-6s from oils. When you go to a supermarket, almost all the oils that you see are omega-6 enriched. So without knowing, we're consuming a massive amount of omega-6s. And as we mentioned before, I think the key or the magic word is diversifying our diet and not binging or focusing on one ingredient. We haven't actively chosen to consume omega-6. They're just more available and cheaper than omega-3s. But if we can make the active understanding and pursuit of balancing our diet and increasing the omega-3s, a healthier balance of omega-3 to omega-6 ratio would make sense.
So I know you have to go shortly, so just one more question. What are you working on next?
I am working on 2 fronts. One front is to understand how ApoE4 creates oils in the brain through HDL, and these are HDL particles, and we're trying to make them in the brain for prevention of disease. And a second front would be looking at patients with ApoE4 and disease, and they have neuroinflammation. And we're trying to develop drugs to inhibit neuroinflammation in the ApoE4 diseased brain for those who actually have started developing dementia. Is there anything we can do? So my lab has two groups, one working on the prevention aspect by understanding the oils that ApoE4 makes and how we can change them. And the second part is understanding if you've got ApoE4 and now you have dementia and neuroinflammation, can we mitigate or attenuate the inflammation, and would that have an impact? So those are two things we're actively working on.
That sounds like great research, and I wish you the best of luck with it. Where can people go to find out more about the work you do?
My website, yassinelab.com. I promise to update it. I'm still a one-man show, so we'll probably have to build with more resources a more dynamic website. But I try at least once every couple of months to update it. So you can go to my website, yassinelab.com, and look at our research. And we've had incredible support from a lot of ApoE4 carriers that keep us going. And we want to do our best to try to slow down or diminish the effect of ApoE4 on the aging brain.
That's amazing. Thank you so much for joining me today. It was incredibly interesting.